in this video again we are continuing our journey of just solving different kind of integral forms, and here in this video I am just focusing on this particular form. We'll derive what will be the answer of this particular form, and then based on this particular form we'll be solving some questions. So here I go. Now we have to find the integral of 1 over x square plus a square. Then we will use the method of substitution, and then what should be the proper substitution. If you just look at the form, it's x square plus a square, and you know that in trigonometry there is a formula called 1 plus tan square theta is sec square theta. So if you just assume that x is a tan theta, so x square plus a square will become a square tan square theta plus a square. Take a square common, and this is tan square theta plus 1, and that becomes a square sec square theta. So this x square plus a square is nothing but a square sec square theta. Now when you substitute the x as a tan theta, in this condition the dx should also change. Now so for that we'll just differentiate x is a tan theta with respect to its own order. So it goes dx, x becomes dx, 1 dx, and the tan theta, a tan theta will become a sec square theta and d theta. So our question now becomes I is, at the place of dx you write a sec square theta d theta over, at the place of x square plus a square you substitute a square sec square theta. Now you see sec square cancel, and the 1a from the numerator cancel the 1a from the denominator, and then you will be left with 1 over a and then 1 d theta. So the integration of 1 is x with respect to x, it is x. So integration of 1 with respect to theta will be just theta. So you get 1 by a theta plus c. Since it is method of substitution, then we would like to express our form from theta to x. Here see that x is a tan theta. It means tan theta is x over a. So tan theta is x over a, and then theta is tan inverse x over a. So this becomes 1 by a tan inverse x over a plus c. So now we have found our answer, that integral of 1 over x square plus a square is 1 over a tan inverse x over a plus c. This is the form of integration. Now based on this particular form we'll solve some questions. So I remove this unnecessary part here, and then I'll take some questions. So I have one question: how to find the integral of dx over 20 plus 5x square. So now just look at the form. This is x square plus a square, and this is 20 plus 5x square. So first I suggest that you take 5 common. So this becomes dx over 5 and 4 plus x square. Now this 5 you can keep it outside, 1 by 5, and the remaining part you can write it as x square plus 2 square. So now this is perfectly matching with this form. So its answer will be 1 by 5. 1 by a, and a here is 2. So 1 by 2 tan inverse x over 2 plus c. So answer will be 1 by 10 tan inverse x by 2 plus c. So now this is the answer. I hope that you got it very So I hope that you got this question. Now I'll take another example. Now here I have a question: I as dx over 3 plus 5 sine square x dx. Now this one is x square, fine, but now you have just compare these two. So if you take 5 common, so I write 5 common, then you see you can have dx over 3 upon 5 plus sine square x. So sine square x is different from x because the differentiation of x is 1, but the differentiation of sine x is cos x. It means even if you go for the method of substitution and you assume that sine x equal to something like sine x equal to t, then at the place of dx, like suppose if I write sine x equal to t, then at the place of dx we should get cos x dx is equal to dt. But there is no such cos x present. It means we cannot substitute sine x equal to t, and we should try to convert this trigonometrical relations, expressions into some other forms where we can get the answer. Now, but here you need to have very good understanding over the trigonometry. What is required now? That you know that if I divide the sine square x by cos square x, then I get tan square x. So instead of going for this method, I'll do that. I simply remove this one, is not required. This one right now 1 by 5 is also not required. First we'll try to do that. We will divide the numerator and denominator both by cos square x. Now you can say how. So the answer will get just after few minutes. So here. So if you divide, then here you get 1 over cos square x and 3 plus 5 sine square x divided by cos square x, and I write dx here. It will look better. So just by dividing the numerator and denominator by cos square x, we'll get 1 sec square x in the numerator, and the denominator will have the sec square and tan square, and the sec square is already related to tan square, so we can always convert that sec square x into tan square x, and we will find the denominator as a function of tan x, and since if we take tan x as t, then that differentiation will become sec square x. So now here I go. So 1 by cos square x is sec square x upon 3 over cos square x will become 3 sec square x plus 5 tan square x dx. Now we need to convert this sec square x into tan square x because we want the denominator only to be the function of tan x. So this sec square x is 1 plus tan square x, means you get 3 plus 3 tan square x, 3 plus 3 tan square x plus 5 tan square x dx, and here you get sec square x as 8 tan square x plus 3. Now you see we are reaching to a standard form. Now in this condition, here I go directly, I write let tan x equal to t. Let tan x equal to t. So sec square x dx will become dt, and then here I forgot to write dx. So sec square x dx. So our integral I will now become, this becomes dt over, this one is 8 tan square x plus 3, this will become 8t square, 8t square plus 3. Now we want this into this form, so the coefficient of x square should be unity. So I'll take 8 common, and then I get 1 by 8 dt over t square plus this will become 3 by 8. So I want 3 by 8 to be expressed as square of a quantity, so I better write this whole thing into the square root and then square. Now here I get my perfect form, and then I can apply the formula directly. It goes like 1 by 8 into 1 over root 3 by 8 into tan inverse t over root 3 over 8 plus c. If you refresh it, Can you see this screen? So this one I can write here in this step. So 8 goes, root 8 goes on the top and it will cancel the 1 root down. So this will become 1 over under root 24 tan inverse. This will be root 8t. At the place of t we can write our substitution, that is tan x. So this is tan x over root 3 plus c. So this is your standard answer, that the integration of dx over 3 plus 5 sine square x can be converted into this. Now I suggest that if you have some other forms also, like this one, or you can have something like dx over 5 plus cos square x, that can also be solved very same way. You have to divide the numerator and denominator. This is very important part, and you have to convert this expression denominator as function of tan x, and then numerator, because when you are dividing this by cos square x, numerator necessarily will become sec square x, and when denominator, then you have task is to convert denominator as a function of tan x only. So this 8 tan square x plus 3, if you take tan x as substitution, then you get the sec square x dx as dt, and then you will reach into this form. From here you reach here, and then from here you can reach to this standard form, and there you get your answer. So this is how this particular type of form can be solved. Now we will discuss some other different forms. So here I have another form, that is I equals x over x to the power 4 plus x square plus 1. How will you find the integration of this much? Now you see that this denominator is a biquadratic function with a polynomial of degree 4, and this is a linear polynomial. So if you have to make the substitution, then to get x on the top, better you take x square as something. So I take x square as t. Then what I'll get? So 2, therefore this substitution gives me 2x dx as dt and x dx as 1 over 2 dt or dt over 2. So at the place of this x dx, I write 1 over 2 dt. So 1 over 2 dt, and then there at the place of x square I write t. So this becomes t square plus t plus 1. Now I take this half outside, this is constant, and then down I'll get dt, and this is t square plus t plus 1. I would like to write this as t square plus 2 into 1 by 2t. So just I want to express this as the sum or difference of 2 square. I want this to change as a square plus minus b square form. So here I want to just convert it to perfect square, because it looks like t square plus t plus 1 is like a square plus 2ab plus b square. T square plus t plus 1 can be expressed as a square plus 2ab plus b square form. So just I try to get my 2ab form, so t square plus 2 into 1 by 2t, and then I need this b, by getting 1 by 2 as b, so I need 1 by 4, and then I need to subtract 1 by 4 because I cannot add anything to the question, otherwise question will change. So here you see 1 by 4 added and subtracted, this nullify this effort, and then 2 multiplied and divided. So it's a question, this whole expression is nothing but this very same thing. It means in this form I can write this as 1 by 2 integration dt, and you can write this as t plus half whole square. Then you are left with 1 minus 1 over 4, that is 3 over 4, and that can be written as root 3 over 2 whole square, because 3 by 4 is nothing but root 3 by 2 whole square. By doing so I am getting this form directly. So here I go, and then I can use the formula. Now you can say, why not use method of substitution here? Yes, why not? You can use method of substitution. So let's see, let t plus half is u, so you get dt is equals to du, and then your integral I will become half integration du over, this is u square plus root 3 by 2 whole square. Now we are very close to the standard form, and then you see that I can write this as 1 over 2, 1 over a. 1 over a is 1 over root 3 over 2. So this is root 3 over 2 tan inverse u over this. But okay, so at the place of u I can write this as t and half. Better I just simplify this t plus half as 2t plus 1 over 2. So this u is 2t plus 1 over 2 divided by, this is my this part, divided by a, which is root 3 by 2. So this 2 cancel with this 2, this 2 cancel with this 2, so we are getting 1 over root 3 tan inverse. Now at the place of t, we better write our main substitution, that is x square. So this becomes 2x square plus 1 over root 3 plus c. So this is the answer of this particular question. Now I'll take some other forms. Now here I take one more question, and the form goes like e to the power x over e to the power 2x plus 6 e to the power x plus 14 dx. How will you find this one? Now you can say that we are discussing this particular form and this question looks so weird. How can you compare this form with this form? They are not going to match. But the answer is yes, they are going to match with the proper substitution. Now here you see that e to the power 2x, if you write let e to the power x as t, so you get e to the power x dx as dt. So just assume this dx, or there is no problem in assuming that, because these two are same thing. If dx remains here or dx remains here, it is same thing. So I just write here dx so that at least you can say that e to the power x dx as dt. So there I write dt. Now e to the power 2x is e to the power x whole square. It means this is just t square. So t square plus 6t plus 14. Now I try to convert this as sum or difference of two squares to check whether we can get in this form or not. So how? So write dt over t square plus 2 dot 3 dot t. So this is 2ab, so our b is 3. So we need plus 9. So suppose if I have taken this 9 out of this 14, so I will be left only with 5. So just that much more. If I write plus 9 minus 9 plus 14, you will get the same thing. But it's just like 2 dot 3 dot t means 60, and 9 plus 4. Why 9? Because we need 3 square. That's why I have taken 9 here. And you can assume that I have split this 14 as two parts. One is 9 and another is 5. So this is serving my purpose. So what form now I'm getting? I get dt over t plus 3 whole square plus root 5 whole square. Now we are very close to this. If you just assume that t plus 3 is equal to u, t plus 3 is u. So second substitution I am doing. So we were given the function of x. Now we substituted as function of t. Now again from function of t we are going to the function of u. So if t plus 3 is u, it means dt is du. So our form will become du. This is only I am substituting so that you can see this particular form exactly matching with this form. If I write here u square plus root 5 square. Now you cannot deny that it's not matching, because this is perfectly matching with standard form. And many people, you can start solving from here also. There's no problem with that, but you should exactly know how can the two forms be just identical. So now here we'll get our answer as 1 by root 5 tan inverse u over root 5 plus c. Now you replace u by t plus 3, and at the place of t you write e to the power x. Means you can replace u as e to the power x plus 3. So our answer will become 1 over root 5 tan inverse e to the power x plus 3 over root 5 plus c. This is your I. Means integral of this is 1 over root 5 tan inverse e to the power x plus 3 over root 5 plus c. Thank you very much for this video, and just learn and subscribe and keep practicing. The next video will take another standard form.